Hi viewers, welcome to Gani's YouTube channel. In this tutorial, I am going to explain you how to create crane beam in Tekla structures. This is the request video on how to create crane beam by using welded plates with default PEB tools. By using PDF example, you can see in our PDF example, we have PEB column, flange 180 by 6 and 400 by 5 thickness, and we have crane bracket here and crane beam, and this is supporting plate under the crane bracket like this. I'll provide this PDF example link in the description below of this video. Please download and practice along with this video. Okay, let's start. Open Tekla structures in Indian environment. I'm going to create views first, so click on grid and deactivate this option, direct modification. Then right click on mouse, create views along grid lines. Now type here before grid, elevation on grid. Okay, select copy, Ctrl C, copy and paste here. Then click on create. Okay, you can see now I have view list here and close it. Okay, now I'm going to create PEB column here. You can see in our example we have PEB column with the height 5000, and we have profile, flange and web profile here. So now I'm going to create this one. So go to view list by using the shortcut Ctrl I, or you can click on here window and select here view list to open view list. Okay, now I'm going to create column at this location. So go to elevation on grid A and click on this arrow to open and close it. Now I'm going to create column here. So click on here application components. Otherwise you can also use the shortcut Ctrl F to open application components window. Now here search in the search bar PEB, then you will get default PEB tools here. You will get this tools in every Tekla structure software. No need to install separate tool. So select this option PEB Tekla structures section S94, then select it and close this window and pick the first point here and pick the second point at this location to create column. You can see now column is created. Right click on mouse, interrupt. Now click on window and select this 3D view. You can see by default we have tapered column like this. In our example we have flange 6 thickness and 180 width, and web 5 thickness and 400 straight column. So I'm going to create this column. So to edit this column you need to double click on it. Use the shortcut shift 4 for render view. Now double click on this column to open this option. You can see now we have 800 tapered column, 800 top and bottom 400 web width. Now in our example we have 400 width entirely, so we need to enter top also 400 millimeter. Now go to parts tab. In parts you can change the thickness, web thickness and of outer flange and inner flange thickness and width. So web thickness we have 5 thickness, so enter here 5. So enter here 5 thickness. Now coming to flange we have 6 by 180, so enter the thickness 6 and flange width 180. Do the same thing, inner flange also same, so 6 and 180. Now click on modify to see the result here. You can see now we have straight column. Then click on modify, apply, OK. Now go to elevation view once again. You can see you will get like this. Now going to take another elevation view, elevation on grid 1. So click on here and select elevation on grid 1 like this. Okay, now I'm going to place this column exactly at the middle. So select this column, then right click on mouse, click on here move and pick the midpoint, then click on here to place here at grid intersection point. You can see now this column exactly at the middle of this column grid. Go to top view, view list, select the plan at 0 and click on here this arrow to open plan view and zoom it here. You can see now this column exactly at the middle of this grid. Okay, now I'm going to create crane bracket. So click on here window and select this 3D view, some 3000 level. So you can see in our example we have crane bracket at 3000 level. So go to elevation along grid 1. So window and select this elevation on grid 1 and I'm going to place here. Okay. Okay, you can see now we have crane bracket projection 300 millimeter. So click on here window and select this PEB tapered section S94 component and pick the first point at grid intersection point here 3000 level. If you're not getting the snap symbol, you need to activate here. You can see snap to intersection point, click on this to activate and then pick the first point and now zoom out and pick the second point. Don't click on it, just place the cursor at the middle of this grid and enter the value 300 millimeter projection, then click on enter to create crane bracket like this. Right click mouse interrupt. You can see now this crane bracket projection should be 300 millimeter. If you want to check, then click on edit and select this measurement and select this horizontal distance and zoom it and pick the first point at here and zoom it and pick the second point here and place it. You can see now here 300 millimeter projection. Okay, now we're going to change the crane bracket profile. Okay, click on here PDF. We can see now here crane bracket web 300 by 4. So we're going to change the web and flanges also. Double click on it, go to 300 by 4 thickness. So you need to enter here 300 web, click on modify. Now go to parts and we need to enter here thickness 4, click on modify. Now coming to flanges, we have 5 thickness and 180 width. So enter 5 thickness and 180 width, then click on modify, apply, OK. Now coming to in our example, we have supporting plate at the bottom of this crane bracket. We need to create this plate. So go to elevation along grid 1. So click on window and select this elevation on grid 1 and we're going to place the plate here. So width 300 and depth we require 200 millimeter. So click on the steel tab and select this plate and zoom it and pick the first point here at the bottom of this flange and pick the second point at the corner and you need to depth we require 200 millimeters. So just give the direction, don't click on it, just place the on the edge. You can see you'll get this snap symbol at the middle. So just place it and enter the value. We require 200 millimeters, so enter 200 on your keyboard, then click on enter on your keyboard to create the next point here. Now we need to close the plate, so pick the initial point at here to create a plate. You can see now plate is created. Right click mouse interrupt, click on space, right click on mouse redraw view to erase this checking dimension. You can see now we have plate. Click on window and select this 3D view and zoom it here. To get render view, use the shortcut Ctrl 4 for members. Now you can see now we're going to change this plate thickness. So use the shortcut Ctrl R and pick the rotation point here and use the control and mouse middle button to rotate about required point like this. We are going to change this plate thickness. So double click on this plate to edit. By default, we have plate profile here, plate thickness 10 millimeter. In our example, we have plate thickness here 8. So we need to enter the thickness of this plate 8 millimeter. So enter here. After PLT, remove 1 and 10 and enter here, replace with 8. then click on modify. You can see now this plate thickness should be 80 millimeter. You can see at depth it should be middle because the thickness will be on both side. You can see this point exactly at the middle, and now from middle to left side 4 millimeter and middle to right side 4 millimeter. So to make sure this should be at the middle, and close it. Now we have crane bracket and supporting plate also we have. So now I'm going to create this beam, crane beam. Before that, we need to check this drawing should be included, assembly drawing should be included. This drawing column with a crane beam and plate. To cross verify, select this column. Before that, you need to select here, select object in component, and then select this web or flange. Then right click on mouse, inquire and assembly. You can see now in this assembly we have only 3 parts, web and 2 flanges. You can see, scroll it down. Under the parts you can see 1 and 2, 1 plus 2, 3 parts. That means 1 web and 2 flanges. This crane bracket and the supporting plate also included in this assembly. So we need to weld this part to main column. So click on here edit and select this weld symbol and pick the main part as a this flange, zoom it and pick the main part as a this flange, and pick the secondary part as a this web. You can see now this crane bracket also included in it. So now we're going to cross verify once again. Click on space, right click on mouse, redraw view, and select this web, main column web, then right click on mouse, inquiry and assembly. You can see now this plate and top flange and bottom flange also included in this assembly. You can see the part list number quantity. You can see we have 5 plus 1, 6. That means we have main member this one web 1 and remaining 1, 2, 3, 4, 5. 5 plus 1, 6. Okay, you need to included this plate also in this assembly to generate entire column, bracket and this plate in assembly drawing. So we need to weld this part also. No need to worry about this. We should be welded this one, not like that. We need to mention the weld symbol and weld size in the drawing. So no need to worry about the welding. We are welding only this one, this flange versus web. We are going to weld only the purpose of including this part in the assembly drawing. Okay, in assembly drawing we are going to mention how to weld and how much weld size we required. Okay, now we're going to weld this plate also in to this main member. So select this weld and pick the main part as a flange and pick the secondary part as a this plate. You can see this plate also included in the main assembly. So right click on mouse, interrupt, click on space, right click on mouse, redraw view. We are going to check once again, select this plate, right click on mouse, inquiry, assembly, and scroll it down. You can see this plate also highlighted yellow color. That means this plate and this flange and web and this flange is included in this main assembly. You can see we have quantity 6 plus 1. 1, 2, 3, 4, 5, 6, and this is the main member, treated as a main member. So 6 plus 1, 7. Okay, that's it. Now this entire column will be generated as a one single assembly set. Okay, now I'm going to create a same column at here to create a crane beam on crane bracket. So drag and select this entire column, right click on mouse, copy and zoom it here. Click here at, pick the first point at here and pick the second point to place the column at this location. So click on grid intersection point to place the same column at there. Right click on mouse, interrupt. You can see now we have 2 columns. Now click on here select component option. To make sure to inquire, to check the inquire, it should be select this one, select object in component when you inquire the object for assembly. For example, you can see if it is in select components option, then click on it, right click on mouse, inquire, you will get the component details. You won't get the assembly details. To get the assembly details, you need to select this option, select object in component, then click on it, right click on mouse, inquire, then click on assembly to check the assembly set like this. Even if you want to weld the two members, between two members, you should be select this one, select object in component. Okay, for example, select this one, select component once again. Now we're going to create crane beam. So go to top level window and select this view list and select this planet 3000. Now I'm going to create crane beam between these two brackets. So select this beam, we required welded plate beam, so click on here component, application components, then select this PB tapered section S94 component, then close it and zoom it here and pick the first point. For example, we're going to pick the first point here, first point at gradient section point, and pick the second point at this gradient section point to create a member, welded plate member. Right click mouse interrupt and click on window and select this 3D view. You can see by default we have beam placed at the middle of this column. Now I'm going to move this beam later, so double click on it. I'm going to change this profiles first. So in our example we have a web 250 by 4 thickness. So web 250, we need to enter here depth 250 and thickness 4, so enter here web thickness 4. Now coming to the flange, now flange thickness we have 150 by 5, so 150 is the width, so we need to enter here 150 and we have thickness 5. Okay, then click on modify to see the result here. You can see now this should be 150 by 5 and 250 by 4 thickness. Apply. Okay, now I'm going to change the position. So now I'm going to move this beam on this bracket. So click on here and select this planet 3000 and zoom it here and select it. Right click on mouse, move and pick the first point here and place, zoom it and place exactly at the middle. You can see now we have beam like this. Now we're going to move inside, so on edge. You can see in our example we have exactly at the edge of this crane bracket, on crane bracket, you can see. So I'm going to move inside, so select this crane beam, right click on mouse, move and pick the first point here, origin point, and destination point we need to click on here to move up to in this position. You can see like this. Now click on window and select this 3D view. You see currently we have the pick point position from point to downward direction, we need to move upward direction, so double click on it. Now I'm going to change this direction. You can see here currently we have taper left side, we need to select the option on right side, click on here and select 1, 2, third option, then click on modify, apply. Okay, you can see now this crane beam exactly at the top of this bracket like this. Okay, now click on window and select this planet 3000. Now you can see this crane beam should be from this edge to this edge of the beam, because we have only 2 columns, so we're going to move this crane beam on this side. Otherwise you can create a new member also, just delete and click on here and select this PB member once again and pick the first point in this corner and pick the second point at this corner. Right click on mouse interrupt and select it and right click on mouse, move from this point to this point like this. Now close this window and 3D view. You can see now we have crane beam like this. Now we're going to crash verify this beam profile, so double click on it. You can see 250 by 4 and 150 by 5. We have previous profile like this. Okay, now I'm going to create the bolting between this crane beam top flange to then crane bracket top flange to crane beam bottom flange. We're going to bolt there. So in our example, you can see now we have bolting like this. We have 100 gauge and 80 pitch like that. So I'm going to create this spacing and bolting there. So go to come here. Now we need to select the bolts, so click on steel and select this bolt option, and we need to select this option, select object in component to select a specific flange. So click on the flange as a primary part and secondary part as a this top flange. You can see now have two parts are selected. So press this mouse middle button and now we're going to pick the direction. So for example, we're going to pick the direction. You can see window and select this planet 3000. Now we're going to select the direction at here, zoom it and pick the first point at this corner and pick the second point at this corner to identify the direction of the bolt in the x direction. Local x direction of the bolt will be like that. Right click mouse interrupt. Now default we have this bolt like this. Now going to enter the bolt number of bolts and spacing between these bolts. So double click on it on this bolt. You can see for example we're going to take this bolt size 16 millimeter and you can change this standard bolt standard here according to your requirement. Currently we're going to take 8.8 XOX and now scroll it down. Now we're going to enter the x direction. As x direction indicates the which direction we have picked the first point and second point is the x direction of this bolt array. For example, you can see in our example we have 100 millimeter in the x direction, so we need to enter here 100 millimeter and 80 millimeter in opposite direction means y direction. So enter here 80 millimeter. Now click on modify to see the result. You can see you will get like this. Okay, now I'm going to move this bolts. So close it here, right click mouse interrupt. Now it should be at the middle of this beam. So select it, right click on mouse, move and pick the point here and pick the second point at the middle of this beam. So click on here to place the bolt at the middle of this beam. You can see now we need to move this bolt array in vertical direction also at the middle of this bracket. So we already know the spacing between these two bolts are 100 millimeters, so we need to move 50 millimeter vertical direction. So select this bolt, then right click on mouse, move special linear, and in the local coordinate you can see y direction. We need to move y direction 50 millimeters, so enter here 50, then click on move, then OK. Right click on mouse interrupt, click on space, right click on mouse, redraw view. Now click on window and select this 3D view. You can see now bolts are placed exactly at the center of this beam and bracket according to this example, in this example. Okay, now use the shortcut control R and pick the rotation point here and use the control and mouse middle button to rotate. You can see you can rotate like this. Okay, similarly you can place the same bolts at here Just you can copy this bolt array also. For example, you can see, now select this bolt. Now use the shortcut Ctrl C for copy and go to window and select planet 3000. Now pick the first point, origin point at a greater intersection of this column, and pick the second point at here destination point. Click on here to place the bolts. Click on space, right click on mouse, 3D view. Now click on window and select this 3D view. You can see now I have bolts at this location also. Use shortcut Ctrl R and pick the rotation point here, and use the control and mouse middle button to rotate like this. You can see I have bolts at this location also. Now coming to drawing creation, right click on mouse, interrupt. Now I'm going to create fabrication drawing for this column. So before that we need to create numbering. So click on here drawings and reports, and click on here perform numbering, and click on here number modified objects. Then click on here save numbers. Now numbering has been completed. Now I'm going to create fabrication drawing for this column. So to make sure it should be select object in component option, and then select it, and to activate this option, and then click on this web of this column, then right click on mouse, create fabrication drawing. Click on this create fabrication drawing. This software is Tekla Structures 2022 version. If you have older version, you will get create drawings, and in subcategory assembly drawings like that. Currently we have this option create fabrication drawing. So click on this create fabrication drawing, and we record only assembly drawings. Type A indicates the assembly and W indicates the single part drawing. Currently we record only assembly drawing, so remove this tick mark. Single part drawing we required only assembly, so select it and then click on and move upward direction, then click on create to create the drawing. You can see at the bottom of the screen one drawing created successfully. So drawing created. So now I'm going to open the drawing. So use the shortcut Ctrl L for drawing list. Now you can see now I have drawing number 1 marked as number 1. So open, double click on this drawing to open. You can see in our background drawing has been opened. So close this window. You can see now I have simple column, 5000 length of the column, and we have crane bracket like this. You can see in the top view we have crane bracket and this dimension, whole dimensions like this. If you want to place here on crane bracket slotted holes, then you can place this slotted holes also in the bracket. Now close this window. If you want to place the slotted holes, just you need to double click on this bolt option. You can see now we have here slotted holes option here available. For example, if you want to place the first hole, special hole as a slotted, then tick on here, then this option will be activated. You can see if you don't have this tick mark, these are gray color, you want to edit it, so you need to click on here, and then these options are available. Then slotted hole, you need to enter here extra, how much do you require to create a slotted hole on this beam. For example, you can see from the head of this bolt to first plate, if you want to create a first plate slotted holes, then you need to tick mark here first one. You can see first one indicates the crane beam slotted holes here. If you want to create the slotted hole in the bottom flange plate, for example bracket plate, then you need to remove this tick mark and you click on here and then enter the values for second plate. That means this top of this bracket flange. For example, if you want to place the slotted holes here in the X or Y direction, for example if you want to place the extra holes instead of tolerance, you can see currently we have tolerance here, tolerance 2. Instead of this tolerance or tolerance 2, you need to enter the extra hole size. For example, if you want to enter 2 extra, then click on modify and close it. Now we're going to check the drawing in drawing. So open the drawing list by using the shortcut Control L and double click on to open. You need to perform numbering because we have changed the whole size, so you need to tick mark here and click on perform numbering and click on here save number and close here. It should be slotted holes here, so do one thing here. I'm going to check in the model, use the shortcut Control R and pick the rotation point here. Use the shortcut Shift to 2 for transparent. Now we're going to change the slotted hole once again, so double click on it, open. This is only for single bolt. We need to enter the entire bolt, so select this one and then double click on it to open like this. Now I'm going to change this x direction to, for example, in y direction we're going to check 4 and tolerance we're going to make it 0. Then click on modify. You can see it has created slotted holes in the bottom plate. For example, we're going to increase here. For example, let's take 6 millimeter, modify. You can see now we have created slotted holes in the bottom plate. Okay, now close it. Now close it. Now click on space, right click on mouse view. Now I'm going to cross verify this bracket. So go to drawing list. Now remove this drawing, both drawing, delete. I'm going to create once again fresh drawing. So use the shortcut Shift to 4 for render view. Now select this option, select object in component and select this web. Then right click on mouse, create fabrication drawing. Then click on here perform numbering. We record only assembly, so remove this one and then click on create. Then click on save number. Now go to drawing list by using shortcut Control L. And now we have drawing here. Double click on to open and close this window here. You can see now we have slotted holes like this. Okay, similarly you can create slotted holes in the crane beam also if required. You can do like this. Okay, then close the window here. Okay, that's it about how to create crane bracket or crane beam in Tekla structures by using default PEB tools or welded plates. Okay, if you like this video, please like it and share it, and please click on thanks button at the bottom of this video and send few amount for supporting me. Okay, thank you.